So the blue family is an n equals 5 bicentric family of polygons. I'm also showing in its interior the locus of its vertex centroid C0, it's going along a circle, and the locus of its area centroid C sub 2. Both of them are just traveling along distinct circles. I'm also showing here the projective image of this Poncelet family under some chosen projectivity. In this case here, it's a full projectivity. The bottom two entries here are non-zero. So you can see here that this black circle is sent to this dashed black ellipse, and the brown caustic is sent to this dashed brown caustic here. Now what I'm looking at right now is the locus of the vertex centroid C0 prime and area centroid C sub 2 prime as I jog my blue Poncelet family. And both of them, as expected, are sweeping ellipses. Now, interestingly, as you can see in these numbers up here, the aspect ratio of both these loci is the exact same aspect ratio of the projective image of the outer circle. So, the first line here is showing me the aspect ratio 1.536 of this, the image of this outer conic here, which is a circle in the bicentric family. And you can see that the aspect ratio of these two loci seems to be the same. The orientation of these loci is also fixed and is basically copying again the orientation of this outer ellipse, the dash black. Now what I want to investigate here is what happens to these loci as I move my caustic. So I have a two-dimensional family of caustics. I can, for example, make the center of the brown caustic in the bicentric system move radially, adjusting it by some appropriate formula. The one that I'm using is called Richelieu's formula because it's an n equals 5 system. But you can see here that this radially moving brown caustic is being adjusted so that the blue family remains closed in 5 iterations, right? So here it's, and as I'm doing this, I'm also observing what's happening to the aspect ratio of these two objects here, the two loci, C0 prime and C2 prime, vertex centroid of the projected image and area centroid of the projected image. And as you can see here, as I move my my caustic, my pre-image caustic radially, the aspect ratio of these loci modulo some numeric error is basically remaining constant and continues to be the same as this circumscribing dashed ellipse here. Also, the orientation continues to copy that of the circumscribing ellipse as I move the caustic radially. What happens when I move the caustic rigidly about the center of the bicentric system? So I can do this over here, and you can see here that the two loci of C0 prime and C2 prime, the green loci, while they change their area, okay, they visually are keeping their eccentricity. It continues to be aligned with the eccentric, identical to the eccentricity of the outer black conic, projective image of this black circle, and also with the aspect ratio of that black conic. So these are all the same numbers. So it looks like there is, and I can, of course, I can vary my projectivity here, and these facts are going to continue to hold, okay? So it seems that these two loci are only dependent on the projectivity M, namely, they will copy the axis and aspect ratio of the projective image of this outer circle here on my pre-image, my bicentric pre-image. A question that remains to be answered is what happens in the case where I have, so right now my caustic family can be varied along a two-dimensional family, right? I can rotate it and I can change its radial position. What happens if I have now the four-dimensional complete set of caustics that subtend, for example, an n equals 5 Poncelet family? So imagine defining these caustics by its two foci, F1 and F2, so you have 4 degrees of freedom, and then adjusting the aspect ratio of such a caustic. Or you could think of it otherwise. You could think of the 5-dimensional family of potential caustics with Cayley, the Cayley condition that closes n equals 5 acting as a constraint, so you have really a 4-dimensional set of caustics. So what's going to happen when I have a full, when I sweep a full four-dimensional set of caustics that subtend a generic n, in this case here, n equals 5. For the n equals 3 case we saw in previous videos, and I'm going to leave a link on the upper right, we saw that the aspect ratio and the orientation were independent. So maybe we're going to get a similar phenomenon here. Okay, so I'll see you in the next video.